part 2. You then import that schematic into Ultiboard, and then you need to assign footprints to the components that you selected in your schematic. So you place resistors, chips, capacitors, buttons, variable resistors, all this kind of stuff, and every single one of those components is going to need a footprint to be able to place that on a PCB, and then to be able to link the legs or the connections of your components together in the correct order. So when you've designed your schematic, every time you link a wire or a point together, it creates a net. And those nets transfer through to your PCB. And it creates what we call a rat's nest. And what that does there is it tells the PCB, using what's known as DRCs, design rule checks, what components are supposed to be connected to what other components. And then it can pick up on whether you've created a short circuit or something fundamentally disastrous before you push it through to production. So once you've imported that into Ultiboard, you'll see this whole bunch of components on top, all these like wires that look like they're connecting straight lines, just point-to-point connections, and they represent the nets. So you would typically then have a footprint assigned to every single component that you're importing into the PCB. So the first thing we're going to talk about are these footprints, because the schematic that you design has abstracted away from the actual component that you're going to use for your end design. So it just represents a component in a model world. So you put a resistor down, for example, but there's probably 20 different sizes and styles of that resistor that you could then choose to go on a PCB. And you need to make that choice for every single component you do. A PCB company or production company won't do that for you. So the first thing you have to do is decide based on the power that's going to go through that particular component. So obviously if you've chosen a resistor that requires 10 watts of power to dissipate through it, then you can't put down a tiny quarter-watt resistor on your PCB, else what you've created is some kind of firework scenario. So that's the first thing that you need to consider, is the component footprint that I'm going to choose for this component. Is it actually available to be able to deal with the power that's going to pass through that component? Okay, that's number one. Number two, the kind of PCB you're designing. So you've got two choices here. You've got the traditional through hole, and you've got the newer surface mount. I can tell you now, if you are able to design in your jobs when you leave here with great qualifications and you get your jobs, the chances of you being able to design a lovely through-hole PCB are absolutely zero. Because they cost so much, they take so much real estate of the PCB. To be able to place the components, you either need to have a wave soldering machine, or you need to have a massive row of people with soldering irons to solder all the time. So cost basically knocks it out. The people that you work for who are probably funding the design that you're designing will want to minimize their costs as much as possible, and that means you're going to get to use as little through-hole components as you can. So that's the second thing you need to consider, the type of board that you're going to do. Are you going to do a through-hole where the legs drop through the board? And another thing about through-hole is that you need to drill the holes. The PCB manufacturer will have to drill the holes, and if you've got loads of holes, your costs will go up. So we kind of steer away from that in this day and age. Also, the parasitic impedances and other such nasties are much greater in through-hole components than they are in surface mount components, because there's more metal, there's more traversing of electrons, there's more corners, all this kind of thing. So the first thing you need to consider is, are we going to be using a through-hole, which would look typically a leg, a resistor, and then another leg. Here I've got some examples up here. Big capacitors, two legs on there, they need two holes, go through the board so you can stick it in solder. Sometimes you have no choice with this kind of component because, again, depending on the capacitance, it may not be available in the surface mount. Other examples, here's the resistor, 2 legs, typically they'll get bent in some way, pushed through a PCB and then soldered. Yeah? This is really older technology, really great for throwing together a breadboard design and prototyping, but in your end design, where it's going into manufacturing, you want to make 100,000, 1 million PCBs, it's going to be too cost prohibitive.